Good morning. Thank you very much, Mumbai First, for having me here today to talk about climate change, its impact on coastal cities, consequent adaptation, and of course the topic of finance, which one has to come to eventually. These things have to be paid for. In my presentation today, I will talk about 5 messages. The first one is obvious. It's incontrovertible that climate change is here. And I think even the skeptics are probably convinced with the heat wave in the north of India, or even if you look at the Mumbai Climate Action Plan, it several times mentions the heating of the Arabian Sea and the consequent increase of storm activity in and around Mumbai. We saw a lot of that last year, or last couple of years, as we were, many of us at home, and noticing these things more than we would otherwise do. So this is one. I think it's incontrovertible that the climate change is here. I think the second thing that, and I'll talk about this with some evidence, is that small changes in the climate leading to small physical changes, low levels of sea rise, slight increases in flooding, actually have a disproportionate impact on physical infrastructure, on assets, and eventually on destruction of property or life in many cases. So small changes make a big difference. It's a disproportionate impact. It's a multiplier effect that we are seeing happen in many, many places. I think this is particularly true of flooding and coastal storms, both of which many coastal cities, including our own, are exposed to. So that's 2. I think number 3, I would say, is that Mumbai is particularly exposed, partly for the way it's built and partly because of the way population is distributed in the city. And of course, the other dimension that's important here is the ability of the city to adapt. The fourth message is that cities are beginning to do things about this, including our own. The Climate Action Plan is one example of things that the city is doing, but even cities which one would consider advanced on the journey are still starting on it. So we are very early in this journey. There's a lot to learn, and there is even more to do. Maybe specifically for Mumbai, my 5th message would be that the Mumbai Climate Action Plan is a very good start. Superb set of consultations, a whole bunch of ideas out there. I think the challenge will be to get these implemented, and get these implemented in the right order, the ideas in there, and get them implemented fast to protect our population and to protect our assets. So those are my 5 messages from today. Let me give you some evidence behind some of what I'm saying. The first one will not be news around climate risk, and I'm going to focus your attention to the one in the column in the middle, which is that coastal flooding and storm surges. By the way, this sea level rise, while it will flood parts of the world, parts of the land of the world, the bigger risk there is not the rise itself, but the increased flooding that it will cause. So periodic storm surges or higher tides, which will cause periodic flooding, which will destroy much more than just the sea rise by itself. So, you know, we are talking about by another 80 years from now, 21 inches to 60 inches of flooding. That depends on what we do with mitigation, which I'm not talking about today. And then, of course, there are other forces at work which you see on the left and right of this, whether it's heat or drought. And if you take coastal cities and what temperature rise and sea level rise would do, is it would impact almost 1 billion people, 800 million people, 10% of the world's population, across roughly 570 coastal cities in the world. The ones that will be most impacted are in the East Asia, Southeast Asia, and South Asia. 4 out of 5 people who live in these coastal cities will get impacted by 2050. Others will also. So, for example, in the US, 170 coastal communities will have flooding challenges. We hear a lot about Miami, for example. Africa, of course, with even greater challenges perhaps in adaptation. And Europe, of course, with less challenges perhaps in adaptation given their income levels. Now, to the point of small differences making a big difference, small changes making a big difference. You can see this here, right? A half a degree difference. You see on the right, the line there is the temperature rise over 50, 70 years, actually 100 years. And the line in the middle is a 2-degree temperature rise line, and the box corresponding on the top is the one to that. And then there's the 1.5-degree line. So what happens in the 1.5-degree warming is that 11% of the world's land will see significant increase in flooding. A half a degree shift will see that number doubling to 21%. So disproportionate impact, a small change in temperature to a small change in climate to a small change in sea levels to a much larger impact on the physical aspects of the world. Let's shift gears to Mumbai and what happens here. I should also say, before going to Mumbai, very briefly, India is disproportionately impacted. Of course, poorer countries are China, India, Bangladesh. This is just impact of flooding, and this is not coastal flooding. This is all of flooding. And the number of people who will be, number of million people who will be impacted by coastal flooding in a 2-degree warming scenario. And you see 350 million people impacted. If you take all heat stress, flooding, agrarian changes, from 200 million people that are impacted today, there will be 4x as many, 800 million people in India that will be impacted by this, almost half our population. So poorer countries, more impacted. I'm not going to take you through this, but there are parts of India which are quite impacted, but I'll jump to Bombay. So this is the first impact that we see on Mumbai. This is heat stress. So you see on the left the map of India. It's going to impact all of the country, particularly the northern part. You also see the northeast quite substantially impacted because this is measured relative to the normal temperatures there and the rise of temperatures relative to that. How many extra days of extreme heat for that benchmark area, for that area, will we see? So lots of red. But the interesting thing is that the map of Mumbai is all red. Right? So what we expect to see is 40 more days of extreme heat in Mumbai, defined as temperatures exceeding 36 degrees centigrade. So 40 more days than usual is what we expect to see. So heat is something that we have to work on as a city. Urban water stress. We see red all over India, on certainly the western part of India. And you see red all over Mumbai. And here it's not a supply problem, it's a demand issue. This is a growing city with increasing demand for water. The Mumbai Climate Action Plan also talks about the fact that even today, Mumbai has a water problem, but it is not a supply problem, it's an availability problem, and then the demand on top is growing. So water stress in Mumbai is going to be extremely high, more than 80%, and it's a 1.4x increase from what it is today. Some of what we experience. I have a building strike, I have a tanker strike going on. In my building, the tankers aren't showing up today. If we then move to perhaps what's the most important impact on Mumbai, which is flooding, and especially coastal flooding, this is what the impact is. If you look on the chart in the middle on top, that's the riverine flooding that you see and the areas of Mumbai that will get impacted. On the one and bottom is coastal flooding that we expect to see. So the takeaways on this are that extreme precipitation events in India, this is again a 2050 view with the 2-degree scenario of warming, which is probably where we are headed. The impact is 2 to 3 days of extreme precipitation increase in the southern half of India and particularly the northeast. In Mumbai, the 1% probability event, the 1 in 100-year event, will have a significant increase in depth, right? A 4-centimeter increase, 10 centimeter to 14 centimeter on average. Now, remember, go back to, this doesn't seem like a big deal, but go back to my point about saying that small changes physically have a big change or a big impact. Likewise, coastal flooding, which has a much bigger impact on Mumbai, the 1% probability event could increase in depth by 25 centimeters. And 4 centimeters is a lot, 25 centimeters is a huge amount. So that's the impact on Mumbai. Here's a simulation that our climate change group did. We modeled a 40-year flash flood event to assess the impact on Bombay and its suburbs. The average flood depth doubles. The flooded area increases by almost 50%. This is a 5 centimeter plus depth of flooding on average. And the impact on capital stock is twice as much. And this, of course, excludes all of the other reasons why this is an issue, right? 2 to 3 million people living within a kilometer of the coastline, sea level increases that are causing this, and so on. And maybe my last point about Mumbai, before I shift to what other cities are up to. This is a complicated chart, but what you see here is on the y-axis, the risk that cities are exposed to. These are all cities, but there are many of them that are coastal cities, as you can see in there. And then the capacity of the city to address this, to adapt. The capacity is a function of the infrastructure quality and the richness of the city, the GDP and the capital stock that's already there. The risk is a function of the climate hazard that I described a few minutes ago for Mumbai. That's that kind of analysis our climate change group has done across many of these cities, or all of these cities. The interesting thing is that there are a cluster of 4 cities here. The ones on the top right are richer cities with high hazard, but richer cities. You see where Singapore is. I'll come back and talk in a minute about that. The ones at the bottom, again, richer cities, low hazard. And then the ones on the top left, which is where Mumbai is, very high hazard and inability or lower ability to adapt, because either the income levels are lower or the infrastructure quality isn't quite there. So we have a big challenge and we have a low ability to adapt, right? So an even bigger challenge to address. So while I've painted the bad news here, I think the good news is that we're acting on it, and so are other cities. Let's talk a bit about that. I'm going to take you through a couple of examples of what cities are up to. This is a case study from the Ho Chi Minh City, very similar to Mumbai, flooding issues, lots of poor people, areas that are underdeveloped, infrastructure which is mixed in its development in adapting to climate change. So this is a simulation done for what will change in Ho Chi Minh City relative to today as a result of a 100-year flood and in 2050. So on the top left of the visual there, you see that the flooded area of Ho Chi Minh goes up from about a quarter to a third, or a bit more than a third, a 50% increase. The interesting thing is at the bottom left, which is that the depth of the flood goes up by 20 centimeters. That's a lot. Small changes make a big difference. Now, on the right, this is again coming back to the point about disproportionate impact. So a 3x increase in flooding depth, a 1.5 increase in flooded area, leads to almost 5 times as much real estate damage and destruction in value terms. And it leads to 20 times to 80 times as much knock-on effects, right? Knock-on effects including things like partial metro closure, reduction of trips, sewage overflowing, the knock-on effect of that leading to health challenges, blackouts and recovery of substations, and the knock-on effect of loss of electricity, for example. So seemingly small changes leading to big losses, in big economic losses in this case. And of course, what we are not counting for is the difficulties to the citizens of this city. This is just a visual of the same thing. So you see the less red today to the more red today in the Ho Chi Minh City. And you don't need to read the details here, but you see a certain set of damages that the city incurs, whether it's rural communities in the city. Whether it's the rural communities in the city that incur damage, to the large number of damages that you see on the right side as a result of the flood in 2050, the 1 in 100-year flood in 2050. And this includes flooding of substations, flooding of metros. The interesting thing here is that Ho Chi Minh City, the road system doesn't get impacted. They've actually made that resilient already to this kind of flooding. Now, what is Ho Chi Minh City doing and has to do to make this happen? This is to the point of saying we are very early in our journey. We have to protect people and assets. So Ho Chi Minh City, as many of you will know, has the largest reforestation of the coast underway at this point of time, right? But at the same time, they do have to spend almost $1 billion building a dike, in addition to the natural measures that they're taking on their mangroves. They have to build resilience, which is elevating parts of the city and physical hardening of the buildings. They have to reduce exposure. They have to perhaps move populations out of certain parts of the city, more uphill. And then the residual risk has to be addressed with financial instruments, for example, insurance. So that's Ho Chi Minh City. Now let's look at a city which was on the top right of what I showed you, which is Singapore. It's likely to, as you would expect, experience significant coastal flooding. It's not in the top category of cities. I mean, Toyota, Kolkata are in the top category of cities which are going to be the most prone to this. Singapore will be similar to Copenhagen, Hamburg, Venice, Mumbai. Now, this is a city which 25 years ago started planning and adapting for this, even before many of us believed that climate change was real. It's done a lot. So you see that it's built the Marina Barrage, some of the photographs here in terms of the adaptation of things that they are doing. They're building infrastructure resilience. They have strengthened their building regulation. They've strengthened their climate science capability at an extraordinary level, and the flood-related operations. But yet, that city has a bunch of things to do. They have to incorporate climate resilience and adaptation in all of the infrastructure that they are either building or rebuilding or adapting. They still don't have a centralized disaster management system. They do have multiple disaster management systems. They don't have a centralized one. And I'm giving you just a few illustrations. This is a rich city, partially exposed, has been on a journey for 25 years, and yet has a long way to go. So that's back to my third message at the beginning. I'm not going to take you through the details of this in the interest of time, but let me go to my last message of saying, look, how do you get things moving? Okay, so adaptation, and how should one think about adaptation? First and foremost, it's essential, and it pays. So there is a 6-to-1 cost-benefit ratio from adaptation. So every dollar that we invest in adaptation increases resilience and saves $6. That's risk-adjusted for what's likely to happen and the rate at which some of these risk incidents are likely to increase. About $2 trillion of spending will therefore end up saving the world $7 trillion if we do these right. Now, of course, this is a lot of money. It has to be mobilized. But as importantly, it has to be spent right? The right kinds of projects in the right sequence, then that's when these kinds of returns will come. We can end up spending a lot of money without getting the necessary impact. So matching of this is what I'm going to refer to in this last section, and which is also back to the lesson, or how we would want to take, how we should as a city take the climate action plan forward. Now, let me dwell on a minute of challenges, and many of you are city administrators here or engaged with the city, so none of this will be unfamiliar to you. We do have short resources, and particularly our city in our country will always be short of resources for all of the things that we want to do with the city. We do have short-term challenges that we will prioritize over things that are 30 years out. These hazards are uncertain by their very nature. One in a 100-year event, becoming potentially one in a 20-year event. So there's a degree of uncertainty, and what we can't really see, we obviously have a harder time dealing with. And then related to that is that the risk is not very well understood. All the pages that I showed you about Mumbai, these are estimates, these are models. All right, they've been done by smart people, but they're models at the end of the day. So many of these risks are not understood. On the right, you see, therefore, while mitigation is absorbing about 80% of the funds, this is developed country view, of the funds that are made available, adaptation is only 20%. Is that enough? Is a question. So what does a city need to do? There's answers at two levels. One is a set of things that they have to do which are very specific to the hazard a city faces. So Ho Chi Minh City, very similar to Mumbai, has to worry about extreme heat with street trees and cool surfaces, instant flooding that may occur with river catchment management or nature-based solutions, or coastal flooding, likewise with nature-based solutions, etc. Right? So there's a set of things the city has to do that's specific. Toronto's case is different. Buenos Aires case is quite similar to Ho Chi Minh City. Mumbai is probably in the same category. So that's clear. That's something that a city has to do. 2-3 points here. I think the one thing that's probably clear is that as one looks at the benefit and the return, nature-based solutions always rise to the top. I think that has become clear, and we see the stress in the climate action plan in Mumbai on nature-based solutions also reflecting some of that. The second one is that systematic resilience has to complement the city-specific sets of actions, which should be biased towards nature-based solutions. What is in this? Number one is awareness. Some of what we are doing today is causing and creating awareness, but it's got to be much more widespread with our citizens. The second is incorporating risk in all our decisions, climate risk in all our decisions as a city. A good example of that is Toronto with its climate lens approach. Response, very important, operating response. So warning systems, 1 day's worth of advance warning reduces damage by 30%. That's the magnitude of shift that occurs as a result of advance warning. And then enhanced financing programs, right? So, for example, flood insurance. So, a set of actions for the city and a set of systematic actions that have to be done irrespective to make the actions for the specific to the city work. Let me focus on the last one, which is how do we make adaptation investments really focused, really prioritized to make our money and our resources go the furthest. I'm going to illustrate this to you with an example. Unfortunately, I don't have a coastal or a flooding example, so I'm going to use an example from heat on perhaps an approach that a city like Mumbai can take to this. So what you see here is adaptation actions for extreme heat. And on the extreme left is a set of actions under hazard resistance, infrastructure, nature-based solutions, grey defenses, and policies. So you see this list of actions there. In the middle, you have the risk reduction potential of each action. Now, this is the point about, you see many blanks out there, right? So, for example, passive building codes can impact temperature by 2.5 to 4.5 degrees. And of course, they can impact temperature only in some areas. So the benefit score is something. Blue is good, positive, red is not, right? And you see many blanks there. So science, in some ways, has to work to fill those blanks. So we get a sense for what is the risk reduction potential that comes from each of the actions, how much area does it impact. And then on the right is feasibility. What we have to think about is the cost of each of these actions. I talked about the fact that nature-based solutions are lower cost, which then leads to a financial score. One has to think about the infrastructure complexity of implementing those, and then the social complexity, very important in a just transition. Now, when you put all this together, and you, on this box, on the y-axis or the vertical axis, you put the risk reduction potential of each of these actions and the feasibility, which is the financial and physical feasibility of these actions, you get a prioritization. And you see there, in this heat case, street trees, cool envelope treatments, white coloring of buildings, for example, heat warning systems are the highest priority ones. Now, this then has to translate into the implementation plan. Then let me now take these lessons and put them together for the excellent Mumbai Climate Action Plan that's just out. Excellent plan. It's got a detailed sectoral view, lots of good ideas, focus on nature-based solutions, as I mentioned, very focused on consultation, seems to have been built bottom-up. What needs to happen for the city is that these adaptation levers now need to be quantified for the impact that they will have and what will they cost and what the feasibility of this will be, and sequenced and funded appropriately. So this has to be the input that goes into financing these. And maybe one more idea, which is that we have to pick all of our infrastructure, like the Toronto case that I talked about briefly, and make sure that each of these plans, each of these implementations that we are undergoing, incorporate and are made climate resistant. So with that, thank you very much. Maybe just back to my core messages. My point number one was it's incontrovertible, the climate change. Point number two was that small changes, what seem like 5-centimeter increases on average flooding, make billions of dollars of difference in terms of the outcomes that they have. And this is particularly true for cities like ours. It's a small change that makes the big difference. We, India and Mumbai, are particularly exposed for flooding, heat, as well as coastal storms. Cities are beginning to move, but even rich cities, and certainly a city like ours, are very early in the journey. We have to move, but we have to learn as we go along. And then finally, we've got to bring economics into this and the feasibility into this in terms of our actions that we take, and that will lead to the creation and sequencing of the right sets of projects, and therefore we get more bang for our buck. Thank you very much.